That is from SSSCE Core Math 1993 Objective Question number 26. And it reads that P, Q, and R are sets such that P is a subset of Q and set Q is a subset of R. Which of the following are correct illustrations of the given information? So we have three diagrams here. We have the diagram, this, and we have to look at this, and we have it here too, and I. So the first diagram I want us to look at is the I. So first we have been told that P is a subset of Q. So let me write this here. P is a subset of Q. That is that P is a subset of set Q. So we see that here. And the second statement that we see is set Q2 is a subset of set R. So let me add that one to here. Set Q is a subset of set R. And from these two statements, we want to, find a way that we can illustrate these on a Venn diagram or diagrammatically. So how are we going to do that? Let's look at the first one. Now, in the first diagram, first we have, you can see that we have the set P. So set P is a triangle. So the set P is like that. In I, we have the set P like that. Then we have the set Q is a blue circle. Then set R, we have a rectangle. So that is what we see in the I. So let me put the three together. So you can see that we have something like this. You see a small triangle here, and you see P over there. Then around this small triangle, we have a circle that goes around it, and that is Q. Now, let me pause here and say something very small about this here. Now, the fact that the whole of the P is within the Q means that P is a subset of Q. The prefix sub means something that is under, something like a submarine. You see, so it's a subset. It's a set, but it's a sub. So if we are being told here that P is a subset of Q, that is Q is a superset of P, or P is a set that is in the set Q, of course this makes sense because we can see that the set P, which is a triangle in this sense, the whole of P is found within the blue circle that is Q. So this makes this statement true. Okay, so let us go on. And we also have a rectangle that covers the entire two sets, that's the P and the Q. And this rectangle is the set R. So that means the set P is also in R and the set Q is also in R. And we are told that the set Q is a subset of R, so that means Q is in R. Of course, we see that the blue circle is in the red rectangle, so this makes this also true. So that is to say that the diagram I is a correct representation of these two statements. So we can say that I is correct. So we have I here, so this makes A potential correct answer. So we see I here, right? B, we don't see I here, so that this means that B cannot be correct. And here C, we see only I. That also means that C2 cannot be correct. So the only correct answers or potential correct answers could be A or D. Now let's check the second one and see the I here. Is the I also correct? Look at the I here. Now the I, we are seeing R. R is now a triangle, of course, but the diagrams are not important, or the shapes are not important. What is important is the set. But we see the set R. We see R inside Q. So let us see if that is true. Let me scroll down a little bit and then pick this color. So we see R in the I. We see R as a triangle here. And then let me also use this for the Q. See Q as a circle. Then of course we see P. Now P is a rectangle here, is the bigger one. And when we I'm not drawing a proper rectangle, so let me I think that is quite better. Okay, so if I put the three together, what we see is first we see the triangle that is the P, sorry, the set R is the triangle in this case. Then we see the set Q. So we can see that the set R is found within the set Q. But is this correct? If you look here, what is the relation between R and Q? R is here and Q is here. If you read this, Q is rather a subset of R. If you look at the sign, the subset sign, it faces R. So that makes R a bigger set. That is a superset. So R is a superset here because the sign faces R. It's a superset, you see. And if you look at a Q, the sign kind of faces Q with its back, or it doesn't face it with its front side. Let me put it that way. So that makes the set Q a subset, you see. So even by drawing this, telling us that R is found in Q makes the entire thing incorrect, because R is not found in Q. If you write this or draw this, or illustrate it this way, that means that R is a subset of Q. So that means R is found in Q. R is a subset of Q. But according to the statement, Q is rather a subset of R. So this makes the option D also wrong. So this means the only correct answer that we can say or see here is the option A. So this makes the option A correct. Oh, I'm sorry, we checked II rather. So we should also try and check III too. But of course, III cannot even be correct. Why? Because if you look at the options, we have only III here. If C can be correct, then that means that it must also have the I option, because of course the I is also correct. Oh, let us look at the III. What does the III mean? If you look at the III, there are some intersections. Example, P and R intersect somewhere here, and of course we also have P and Q intersecting somewhere here, and then we also have Q and R also intersecting here. So there is nothing like one being a subset of the other. So P is a subset of Q. For this P and Q, it is not true, because if it will be a subset, for P to be a subset of Q, it means the entirety of P must be within the Q. So the whole of the P should be within the Q. But if you look at it, even if P is, say, let's use a circle. If you have a circle, of course there is three set problem. If P is a circle and Q2 is a circle, and then if we are told that P is a subset of Q, then that means P should be within Q. So that means that if we have the set P like that, then the entire set P should be within the entire set Q. But that is not the case that we have in here. If you look at the diagram that we have over there, what we see is that P is rather intersecting with Q. So the entire P set is not within the Q set. So that means the option III is not correct, and the II2 is incorrect too. But I was saying that because first, I was showing you how to solve objective questions. There is no time to waste, because we first checked I and got to know that I was correct. So any option here that should be correct should have the I there. So the potential options that could be correct were the A and the D. And that was the reason why I first cancelled the B and the C, because we saw that the diagram I was correct. And if you look at C, we don't have the I option here. So that automatically means that the option C cannot be correct, right? And if you look at the B2, we don't have the I option also here. That also makes the B incorrect. So if you do it this way, it kind of shortens your time to solve the objective questions in the core mathematics, because I think you have about 1.5 hours and you have to work very hard and very quickly. Thank you. So this is how we solve this question from SSSCE Core Math 1993, objective question number 26. Thank you.